All right, let's talk about the future of mobile networks, because today we're diving into how a really radical new design called Open RAN is becoming the absolute key to one of 6G's most incredible applications, the real-time digital twin. Okay, let's get into it. 100 microseconds. Okay, what does that even mean? Well, that's a tenth of a millisecond. It's like taking the blink of an eye and chopping it up into 4,000 pieces. This tiny slice of time is the response speed that 6G networks need to hit if they're going to create perfect, real-time digital copies of our physical world. The big question is, how on earth is that even possible?
Well, to really get the solution, we first have to wrap our heads around the incredible scale of the problem. You see, 6G isn't just a little bit better than 5G. Nope, it's a massive leap that needs a totally new way of building a network from the ground up. I mean, just look at these numbers. They are wild. We're talking about data rates hitting terabits per second and supporting millions of devices packed into just 1 square kilometer. These aren't just small improvements, you know? They are orders of magnitude bigger than what we have now. This is the kind of power you need to run flawless, instantaneous digital copies of reality.
And right here, this is the heart of the matter. A digital twin, a perfect virtual copy of a factory robot, a self-driving car or tech, even a city's entire traffic system. It completely lives or dies based on the network. It needs to handle a massive fire hose of data with basically zero delay. If the network stutters for even a moment, that digital twin is no longer a twin. It's just an old picture.
So the billion-dollar question is, how do we build a network that can actually handle all this? Well, the answer is a really revolutionary shift in how we think about network architecture, and it's called Open RAN.
You know, the best way to think about Open RAN is to remember the jump from those old flip phones to the smartphone in your pocket. A flip phone was a closed box, right? The hardware and the software all came from one company, and that was it. You couldn't change a thing. But a smartphone, it's an open platform. The hardware is from one place, the OS from another, and you can download apps from literally thousands of developers. Open RAN does exactly that, but for the entire mobile network.
In this visual right here, it shows you exactly what we're talking about. The traditional network, or RAN, is that one big closed-off block from a single company. But Open RAN? It smashes that block into smaller pieces that all speak the same language. You've got your radio unit, the ORU, your distributed unit, the ODU, and your centralized unit, the OCU. They can now all work together through open connections, creating this flexible, mix-and-match ecosystem.
And this whole revolution is built on these 4 big ideas. By splitting the hardware from the software and making everything use open, standard connections, network operators are no longer trapped with just one vendor. This fires up competition, and this is the really important part. It lets us add a new layer of AI intelligence to run the network with mind-blowing precision.
Okay, so let's put the pieces together. Let's see exactly how this new, open way of doing things makes something as insane as a real-time digital twin actually work.
So, just so we're all on the same page, a digital twin is that virtual copy we've been talking about. It's being fed a constant stream of data from the real world, which lets us watch, predict, and even control a physical system from a distance. Now, to get that perfect real-time sync, the Open RAN architecture does something really smart. It basically splits its brain into different parts that all think at different speeds. You can see these control loops here on the diagram. They go from non-real-time for big picture planning to near real-time for quick tweaks, and all the way down to real-time for those instant reflexive actions. And here's the crucial part. It's a division of labor. Think of the near real-time Rick as the strategist. It's the brains of the operation, looking at the bigger picture and making smart calls on a timescale of about 10 milliseconds to a second. But for those actions that have to happen right now, it hands off the job to the ODU scheduler. That's the muscle. It just executes no questions asked in under 10 milliseconds. It's incredibly fast.
So how does all that data get from the real world to that super fast processor? It zips across a special connection called the open fronthaul. The best way to picture it is as a massive, super fast data highway. It connects the radio out on the cell tower, that's the ORU, to the real-time brain, the ODU. And because it's an open standard, it guarantees that all that sensor data from our digital twin can flow without hitting any traffic jams.
Okay, so let's walk through the whole thing. A sensor on a robot arm detects something. That's step 1. Instantly, the radio unit, the ORU, shoots that data across the open fronthaul. The ODU grabs it and processes it in less than 10 milliseconds. That new info gets fed up to the smart strategist, the near RT RIC, which decides on an adjustment. An order is sent POC down and an action is taken. And boom, the loop is complete.
keeping the digital and physical worlds in perfect sync, all within that tiny, tiny window of time.
So yeah, this architecture is incredibly powerful. But what's really exciting is that its potential goes way beyond just this one use case. This is about building a network that's fundamentally more flexible and intelligent for whatever the future throws at us.
By breaking the network down into these open, software-driven, mix-and-match pieces, Open RAN isn't just solving today's problems. It's creating a foundation, a launchpad, that's adaptable enough to handle the amazing applications of tomorrow that we haven't even dreamed of yet.
So the big takeaway here is that Open RAN just creates a much healthier world for networks to live in. It sparks innovation by letting new, smaller companies build cool solutions. It frees operators from being locked into a single, expensive vendor. And maybe most importantly, it creates a network that's built from day one for AI to run the show, making everything smarter and more efficient.
And all of this leaves us with one final, kind of mind-blowing question. The ability to create a real-time, working digital copy of our physical world isn't really the end goal. It's the starting line. Once we can actually do this, the question isn't, how do we do it anymore? It's, what will we build next? Thanks for joining me.